be less dangerous.
Less dangerous, hopefully more exciting one.
Yes.
Okay, so you want to hold this still? Alright, and we're going to practice by pulling to the edge. See how we do with keeping the seal when we pull to the edge.
Alright, we gotta switch because this top one is burning me. You have more calloused fingers than I do.
It's alright. Wait, hold on. They're not,
I don't think they're properly.
No. Alignment is key. Ah, dripping. Thank you. Okay. Ready?
This one is more jiggly.
Okay, now, nothing exploded, but if you watch the color, look at the color at the bottom, look at the color at the top. There's definitely a change going on. Now, what the elements and the molecules are not changing. The only thing that's changing are physical properties. So what type of change do you think this is? Physical change. In fact, it's a mixture. If you were as close as I am, you would see little waves in the water that almost looks like the heat coming off of like a hot sidewalk. That's because what you're really seeing is little waves when you see heat. It's waves in air, this is waves in water. So if you do this at home, you'll be close enough to see those waves.
Get them to hold it, you can get a zoom in.
No, it's just
Pull it up.
Yeah. In order to see the waves, you have to be angled down on it, like I am, with a dark background. So maybe my shirt is a dark background. Can you see it through the viewfinder?
Nope.
Okay. It's quite obvious that this is a much different result than we got with the other one. The data suggests something different happened.
You'll notice that now the bottom one is no longer pure yellow and the top one is no longer pure blue.
While they're not yet at the same color, if we waited a long time, an interesting thing would happen. Just like two things that are touching exchange heat and exchange heat until they're the same temperature, if we waited long enough, these would all become the same color. Unless the blue dye is more dense than the yellow dye, in which case we'd see something different. However, if we waited long enough, since these are the same densities, it'd be the same color. It's cool. I still see evidence of movement in there, and you'll have to trust me on this.
Until they about equal out, it's still going to keep on moving. Until they get about the same temperature, it's going to continue to move.
I love equilibrium.
It's only been about 1 or 2 minutes, same as the last time. But last time you noticed that the colors stayed pretty much completely separate except for at the neck. And now it is definitely not the case.
So, here's the thing. We only have evidence of the color changing. We have to make an inference that the reason the color is changing is because the liquid is actually moving. I personally have evidence that the liquid is moving because I can see those waves. You can't see the waves, so you're going to have to trust me. The reason that they are mixing is because the liquids are moving in a cycle. When liquids move in a cycle because of a difference in heat, a difference in temperature, and they're going in cycles, and I'll give you a hint right off the bat, it's not conduction. What's it called? Did they get it? Hope so. Well, it's convection. This ties into a lot of things in science, and right now, the most important part, this is what's happening in the mantle. Slower, but this is what's happening in the mantle. The hot yellow magma closer to the core of the Earth is heating up. As it heats up, it becomes less dense than the cooler magma at the top. The cooler magma at the top wants to go down. The hotter magma at the bottom wants to go up. So they both go through this little nozzle. One is very polite and goes up this way. The other is...
And that's a scene.
I got too excited.
Last words?
Ask your teacher how it works.